Hi. In section 10.4 of Introductory to Statistics in OpenStax, we are going to talk about the match or paired sample. In previous sections of chapter 10, we talked about the full hypothesis testing with two population or two samples, but we mostly focus on independent sample. But now we want to see how a hypothesis testing works when we have dependent sample. Dependent sample means for every value in the first sample, we have a corresponding value in the second sample. And it usually, the samples that are dependent are usually the samples that are coming before and after a type of treatment or classes, or they are same subject, but they are recorded before and after something. So that's why we call them match or paired sample. So like any other hypothesis test, we need to check the requirement. And if you remember, the requirement for the hypothesis testing for two samples was that the sample be random, the population must be normally distributed, or the sample sizes must be more than 30. In previous section, we said that the samples must be independent, but now in this section, one of the requirements is that the samples be dependent. After checking all the requirements, we need to follow the full hypothesis testing, and I will show you in a table. Yeah. Okay. What are the notation that we use? In this section, since we have dependent sample, we work on the difference between the two values of the sample. So D is the difference between the two values before and after. The first sample minus the second sample. The data entry of the first sample minus the data entry of the second sample. And that's the D. And we always, at the beginning of the problem, we find these differences and we do the whole hypothesis testing just for this value. After finding the differences, we have just one set of data. And it's this remaining steps of the hypothesis test, it's the same as the hypothesis test for one sample. After finding differences, we have a new set of data. So we will have a mu sub d, which is the mean value of those differences for the population, which we use this notation when we are writing null and alternative hypotheses. We also have x bar sub d, which is the mean value of the differences for the sample data. That's the mean of the d values, or sometimes we show by d bar. D bar means the mean of the d values. S sub d, which is the standard deviation of those differences for sample, and n, which is the number of paired data. So as I said, we need to find the d value first, which is the difference between the entries. We usually subtract the first minus second sample. And after finding the d values, we need to find the mean of those values by adding them together, divide by the number of them, and then find the standard deviation of those values. That's the exact formula that we had on chapter 2 for the standard deviation. So if you remember, what the formula for standard deviation was this formula. That's subtracting the mean from each data value, and then s squared, and then add them together, and then divide it by n minus 1. And this formula that exactly come from this formula, but since this time x values are the differences, are d values, instead of x bar, we also say x bar of d, which means the mean of those differences. And we are going to use a t-test for this hypothesis test. So we're going to use a t-table. And for the t-table, we need the degrees of freedom. So to find the critical values, You need to have the degrees of freedom and alpha, which is for one sample or two sample. And this is the formula that we use for T. That's exactly the same formula that we had it in chapter 9 for one sample hypothesis test, which it was x bar minus mu s over the square root of d. When the sigma was unknown, we use this formula. And that's the same formula, but all of them have all of those x bar, mu, and s have a sub d because to show that these are the mean and the standard deviation of those differences. Oh, that's n, sorry. Okay. To find the confidence interval, again, we can find the margin of error by similar formula that we had it, and then add and subtracting by the point estimate, which is x bar. And following all the steps gives us the full hypothesis test. So we check the requirement, we write the null and alternative hypotheses. If we are following the rejection region method, we need to find the critical values and the rejection region first from the t-table. And then after finding the mean and the standard deviation of the differences, we find the test statistic and check if the test statistic falls in the rejection region or not. But if you're following the p-value method, you don't need this step. You just find the t-value, and then after that, you need to use technology to find the p-value. So there is no way that you can find the p-value by tables. You just use the calculators, online calculators, to find the p-value and check if p-value is less than alpha or more than alpha to make your decision. And these are the steps that for a TI-83 or 84 calculators you can follow to get the result. So let's look at an example. He says a golf instruction and a club fitting company claims that the people who play golf can improve the average golf score by taking lessons from one of their coaches. When they mean they can improve their scores, means the scores after taking those classes would be less than the scores before taking the classes. The scores will decrease. The average of golf scores of 8 randomly selected people who play golf are determined before and after taking lessons. Whenever you see samples and you have the result from before and after something, that tells you that you have dependent sample. The results are shown in this table. If alpha is 10%, is there enough evidence to support the company's claim and assume that the average golf scores are normally distributed? Okay, so to follow a hypothesis test, we need to check the requirement. To check the requirement, we say, first, are samples random? Yes. Are samples dependent? Yes. Are populations normally distributed? Yes. Okay, after checking the requirement, we need to write the null and alternative hypothesis. To write the null and alternative hypothesis, remember that we are going to use mu sub d for null and alternative hypothesis. You only need to say if mu sub d, or the mean of differences, is less than 0 or more than 0 or not equal to 0 or equal to 0. How do we find this one? You know that mu sub d means the mean of before minus after. When they expect, in the claim, they expect that the average scores decrease after the lessons, means the mean of after must be less than the mean of before. That means the mean of before should be more, because they expect that the average scores after taking lessons is less than the before. And if you subtract both sides by before, you will see that the mean of before minus after must be greater than 0. It means the mu sub d must be greater than 0. That's the claim. Where do we put greater than 0? On the alternative, because there is no equal sign. So that's the claim. And if the alternative is greater than 0, it means the null is less than or equal to. After writing the null and alternative hypotheses, now we need to find the mean of these differences. We need to find the difference values first. Difference value means subtract these values. What is 96 minus 89? What is 95 minus 90? 95 minus 95, 99 minus 94, 87 minus 91. And after finding the differences, then we need to find the mean and the standard deviation of those values. And I know that 96 minus 89 is 7. 95 minus 90 is 5. 95 minus 95 is 0. 99 minus 94 is 5. 87 minus 99 is negative 4. 104 minus 100 is 4. 105 minus 103 is 2. And 94 minus 100 is negative 6. These are my new values, and I need to find the mean and the standard deviation of these values. Okay, we can find the since we are following the rejection region method, because every time that I work manually on a problem, it must be done by the rejection region method. And using the rejection region method, I need to find the critical values and the rejection region first. When I look at the claim, the alternative hypothesis, I see that I have a right tail test. Right tail test means I only have one critical value. And since I'm using the t-table, I need to look at the t-table to find that critical value. If I want to look at the t-table, I need to know the degrees of freedom, and I need to know area in one tail or two tail. Since I have a one tail test, because it's just right tail, if you remember, when we had one tail means left tail or right. Both of them are one tail test. But if it's a left tail test, we need to keep the number negative. If it's right tail test, the number must be positive. I have a right tail test here. That means after finding the value from the t-table, I need to keep it positive. But to find the value, I need the degrees of freedom, and I need to know the alpha for one tail. Degrees of freedom is n minus 1. How many pairs do we have? We have 8 pairs, and 8 minus 1 is 7. And alpha is 10%. So that means one tail is 10%. So go back and look at the t-table. If one tail is 10% and degrees of freedom is 7, that means your critical value is 1.415. And the rejection region is any number that's greater than 1.415. So that's my rejection. Now I will find the difference values, the mean of difference values, and the standard difference values. So after finding the differences, which I show you on the previous slide, we need to find the mean. Mean means adding all those numbers together and then divided by 8, because we have 8 numbers, and we get the 1.625 for the mean. Sometimes we show the mean by x bar sub t, sometimes we show by d bar. Both of them are the same. And to find a standard deviation, you know that you have to subtract the mean from each of the difference values. When the mean is 1.625, I need to subtract all of 1.625 from all of the d values, and then square those values, add them together, divide by n minus 1, which is 7, and then take the square root. And I get the standard deviation is 4.627. This is how we work on the problem manually, but I don't recommend, because it's very time consuming. So all of the calculators, even the scientific calculators right now, they give you the mean and the standard deviation. Even if you have a TI-38 calculators, you can just type in these values and then it quickly gives you the mean and the standard deviation. But if you want to work manually, which I don't recommend, that's the way that we do. After finding the mean and the standard deviation, we need to use the t-test. We have the formula, we have the mean of those d-values, we have the standard deviation, and then we find this value for the t-test, the standardized test. But since we are using the rejection region method, we need to check if this value is in the rejection region. So in the rejection region method, we said that any number that's more than 1.415 must be rejected, but this number is less. So that means we are not going to reject. So we fail to reject a null. And when we fail to reject a null, since the claim is on the alternative, that means we are rejecting the alternative, which is the claim. So since the claim is on the alternative, you need to use the word support. But since you are rejecting, you cannot support it. So you say there is not enough evidence at 10% level of significance to support the claim that the people who play golf can improve or decrease their scores by taking lesson from one of those coaches. So we cannot support this claim. Let's look at another example. Okay. Feel free to pause the video, work on the problem, follow all the steps, and then check your work. The next example says the campaign staff for a state legislator wants to determine whether the legislator's performance rating number from 0 to 100 has changed from last year to this year. Has changed. That means ratings are not the same from last year to this year. The table below shows the performance rating from the same 16 randomly selected voters for last year and this year. And as you see, these ratings are coming from the same voter. Last year and this year from the same voter. That means these two samples are dependent. If alpha is 5%, is there enough evidence to conclude that the legislator's performance rating has changed? So we need to check the requirement, and the requirement says that the samples must be random. Yes, they are. And sample must be dependent. They are, because both of the last year and this year ratings are coming from the same subjects, same voters. And the population must be normally distributed, it mentioned here. So yes, the problem satisfies all of the requirements. Now we need to write the null and alternative hypothesis. To write the null and alternative hypothesis, remember that we use mu sub d, the mean of differences. Difference means before minus after. Difference means last year minus this year. Okay. They want to know if the rating has changed from last year to this year. Has changed means before is not the same as after, which it means the difference is not equal to 0. That's the claim. Where do we put not equal sign? In the alternative. So the null must be equal to 0. Okay. Now, after writing the null and alternative hypothesis, we need to find the rejection region. To find the rejection region, I need to find the critical value. To find the critical values, since I'm using t-table, I need the degrees of freedom and I need alpha. Alpha is 5%, and the degrees of freedom, since we have 16 samples, the degrees of freedom is 16 minus 1, which is 15. But something that's important to know that we have a two-tail test. When we have a two-tail test, that means we have two critical values. And these, the areas on the two tails are the rejection region. So When I'm looking at the t-table, I need to look at the two-tail row, or since alpha is 5%, so two-tail 5%, and the degrees of freedom, which is 15. So two-tail 5%. Two-tail 5%, and degrees of freedom is 15. And we end up to this number, 2.131. But you know we have two critical values. So that means positive 2.131 and negative 2.131. And the rejection regions are all of the t-values that are less than -1 and more than +1. And after finding the rejection region method, now it's time to find the differences. Difference between the last year and this year ratings. So we subtract these numbers, before minus after. 60 minus 54, 54 minus 46, 78 minus 68. And after finding the values, the difference values, we find the mean of these values, which is x bar sub d. Add them together, divide by 16. And then find a standard deviation, again using formulas or using calculators. This formula is also a shortcut for finding the standard deviation. You can use this one as well if you work on the problem manually. But I will show you on the next example how you can use online calculator that gives you the standard deviation. You don't need to calculate. And after finding the mean and the standard deviation, we need to find the test statistic. The test statistic is the bar minus mu sub d. You know that the mu sub d, it's the mean of before minus after, the mean of differences. And this is always 0. We just need to plug in a number for d bar, the mean of the differences, the standard deviation of differences over the square root of 16, because we have 16 pairs. And then after finding the t-value, we need to check if it's in the rejection region. So the rejection region says any number that's more than 2.131 must be rejected. And this number, the test statistic, is more. It means that it's in the rejection region. If it's in the rejection region, you need to reject the null. And if you reject the null, since the claim is on the alternative, you can support the claim. So you say that there is enough evidence at 5% level of significance to support the claim that the legislator's performance rating has changed. Okay, last example. So in this example, we have a study that was conducted to investigate how effective a new diet was in lowering cholesterol. Result for the randomly selected subjects are shown in the table. And the difference have a normal distribution. Are the subjects' cholesterol levels lower on average after the diet? Are the cholesterol levels lower after the diet? That means after must be less than before. Okay, so we use this claim to write the non-alternative hypothesis. And that says the mean of after must be less than the mean of before. And that tells me the mean of difference, which is before minus after, must be greater than that. But let's start from step 1. Check the requirement. We need to check if samples are random. Yes. We need to check if the samples are dependent, which they are, because they are coming from the same subject, and if the populations are normally distributed. And you see it mentioned here. So yes, we checked all the requirements. Now we need to write the null and alternative hypothesis. To write the null and alternative hypothesis, we use the claim. And as I explained, since it says we want to have a lower average after the diet, that means the mu sub d must be greater than. And we put that one on the alternative. So when you're writing the null and alternative hypothesis, you say the mu sub d must be greater than 0, which is the claim. And if the alternative is greater than, that means the null can be less than or equal to. Okay, let's just leave some space for finding the difference values. So null is alternative is the claim. Okay. Now we need to find the critical values. To find the critical values, we're going to use the t-table. To find the critical values, we need degrees of freedom. Since we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs, 9 minus 1 is 8. And because of the alternative, which is greater than means right tail test. So I expect to have one critical value, and the rejection region is the area to the right. So we have the area on the right, one tail, and the degrees of freedom. So looking at it, so one tail 5%, and degrees of freedom is 8. Is that correct? Yeah. And the answer that we end up is 1.86. Is that correct? Yes, 1.860. Okay. So the critical value is 1.860, and the rejection region is any t-value that is greater than 1.860. After finding the rejection region, now it's time to find the differences and find the mean and the standard deviation of differences. So I'm going to add another column to this table to find the differences. Before minus after. What is 209 minus 199? 10. What is 210 minus 207? 205 minus 189. 198 minus 209. 216 minus 217. 217 minus 202. 238 minus 211. 240 minus 223. And 222 minus 201. After finding these d-value, you need to find the mean and the standard deviation of these values. Just put these numbers in calculator and find the mean and the standard deviation. I'm not following those manually steps. And I get that the mean must be and the mean is 10.78, and the standard deviation of these values are 11.86. After finding the mean and the standard deviation, now it's time to find the test statistic. So write the formula for test statistic. You know mu sub d is always 0. That's 0. So d bar, which is 10.78, minus 0, standard deviation, over the square root of n, which is 9 pair. And after finding the test statistic, we get 2.727. Now it's time to make our decision. For the rejection region, we said if t-value is more than 1.86, it must be rejected. And this number is in the rejection region because it's more than 1.86. If it's in the rejection region, we need to reject the null. If you reject the null, that means you have enough evidence to support the alternative, which is the claim. So we say there is enough evidence at 5% level of significance to support the claim that the cluster level is lower after new diet, at which it means that treatment was effective. Now let me show you how you can use the online calculator. You open the online calculator. So the calculator number 20, which it says two dependent samples with data. And when you click on this one, it asks you to type in all of the data values in the first and the second sample. So we type in all of the values, and I did it here for you to save time. Now I need to choose the claim. The claim was on the alternative. So if you look at the claim says the mu sub d must be greater than 0. So I choose greater than. Now it's asking find the confidence level, and you know that the confidence level is always 1 minus alpha. If alpha is 5%, that means the confidence level is 95%. And then we calculate. And when we calculate, we have the test statistic, which is 2.72. And you see that manually also I got the similar answer. And the difference in decimals is okay because we usually round the numbers when we finding the d bar and s sub d. But the numbers from the online calculators are more accurate. But you know, the online calculator always gives you the p-value. If you have the p-value to make your decision, you need to compare the p-value with alpha. Alpha is 5%. Now you ask, when alpha is 5%, is p less than alpha or more than alpha? So you see that the p is less than alpha. And if p is less than alpha, less than or equal to alpha, you need to reject the null. And we did the same here. Because when we use rejection regen method, we also decided to reject the null. So they are the same, just the methods are different. And if they ask you about the confidence level, you can use this lower bound and the upper bound. I hope that helps.